For most of human history, half the moon was completely invisible to us. Not metaphorically, not because of clouds or atmosphere or bad telescope technology. Literally invisible because the moon rotates at exactly the rate needed to keep one face permanently pointed toward Earth and the other permanently pointed away. Every civilization that ever looked up at the night sky, every astronomer, every poet, every navigator who used the moon to cross an ocean, saw the same half. Always the same half. The other side was as unknown as the bottom of the deepest ocean, and for most of human history, almost as unreachable. Then in 1959, the Soviet probe Luna 3 swung around behind the moon and photographed what was there. The images were blurry, low resolution, and historically staggering. For the first time in the entire existence of our species, human eyes looked at something that no human being had ever seen before. The far side of the moon was real. It had terrain. It had features. And even in those first crude photographs, it looked different from the face we knew. Different in ways that took decades to fully appreciate. Different in ways that we are still, in 2025, actively trying to explain. Different in ways that become more unsettling the more data we collect, and the more sophisticated our understanding of planetary science becomes. Because the far side of the moon is not just the back of something familiar. It is a fundamentally different world that happens to be attached to the front of something we thought we understood. And the images, real images from real spacecraft, built up over 60 years of increasingly detailed observation, show something that planetary scientists are genuinely struggling to fully account for. This is what those images actually show. And this is why it matters. Start with the most obvious thing. The thing that you can see immediately when you compare orbital photographs of the near side and the far side by side. The near side, the face you see every night, is covered in vast dark plains. These are the Maria, from the Latin word for seas, named by early astronomers who mistook their flat, dark surfaces for bodies of water. They are not water. They are ancient lava flows, eruptions from billions of years ago that flooded enormous impact basins and cooled into smooth, flat plains of dark, basaltic rock. The Maria cover roughly 31% of the near side. They give the moon its familiar face, the pattern of light and dark that humans have been drawing and painting and writing about for thousands of years. Now, look at the far side. The Maria are almost entirely absent. Less than 1% of the far side is covered by volcanic plains. Instead of smooth, dark regions punctuated by craters, the far side is an almost uninterrupted wall of craters. Craters on top of craters. Ancient craters filled with newer craters. The oldest craters so battered and overlaid with subsequent impacts that they are barely recognizable as craters at all. The far side looks like something took a hammer to it for 4 billion years without pause. And compared to the near side, that is almost exactly what happened. This difference is not subtle. It is one of the most visually dramatic contrasts on any object in the solar system. Two hemispheres of the same body, the same size, the same age, the same distance from the sun, and exposed to the same bombardment history. And they look almost nothing alike. That asymmetry is the central mystery of the moon. It is the thing that every model of lunar formation and evolution has to explain, and no model yet proposed explains it completely. The visual difference between the two hemispheres is striking. What lies beneath the surface is stranger still. When the Grail mission, two spacecraft flying in formation around the Moon and measuring tiny variations in their distance from each other caused by gravitational differences below, mapped the Moon's gravity field in extraordinary detail, it confirmed something that earlier data had suggested but not fully established. The crust of the far side is dramatically thicker than the crust of the near side. The near side crust averages roughly 30 to 40 kilometers in thickness. The far side crust averages roughly 50 to 60 kilometers, with some regions significantly thicker than that. This is a difference of tens of kilometers of rock, wrapped around half of a body that is 3,474 kilometers in diameter. It represents an enormous asymmetry in the physical structure of the Moon itself, not just its surface appearance. Why is the far side crust so much thicker? The leading explanation involves the early history of the Moon, specifically the period immediately after it formed, when the entire outer layer of the Moon was molten. This magma ocean cooled over millions of years, crystallizing into the crust and upper mantle we see today. The theory proposes that Earth itself, still hot and glowing from its own formation process, was warm enough to slow the cooling of the near side of the Moon, while the far side cooled faster. Faster cooling would produce a thicker crust. This is a plausible explanation. It is supported by some evidence and has real scientific merit. It is also not universally accepted, and it doesn't fully account for all the observed differences between the two hemispheres. Some researchers have proposed a competing hypothesis: that a second, smaller moon once orbited Earth alongside our current moon, and that this companion eventually collided with the far side in a slow, low-energy impact that piled additional material onto the far side's crust rather than excavating it. This would explain the thickness difference and potentially some of the compositional differences between the two hemispheres. Neither hypothesis fully satisfies the observations. The crust thickness asymmetry remains a genuine open question in planetary science, one that new data keeps complicating rather than resolving. If you want to understand how violent the far side's history has been, start with the South Pole Aitken Basin. The SPA Basin is the largest confirmed impact crater in the entire solar system. It stretches roughly 2,500 kilometers across, wide enough to span the continental United States from the Atlantic coast to the Rocky Mountains. It plunges up to 13 kilometers deep. The mountains along its rim reach summit elevations of 8,500 meters, comparable to the highest peaks on Earth. If you place this crater on a map of the United States, it would swallow everything from Texas to Virginia. It sits almost entirely on the far side, centered near the lunar South Pole. And it is so old, formed approximately 4 billion years ago, or near the beginning of the solar system's violent early period, that billions of years of subsequent bombardment have battered and degraded its interior until the floor is itself covered in thousands of smaller craters. The images of the SPA Basin from orbital cameras are extraordinary. The basin floor, photographed by instruments including the Lunar Reconnaissance Orbiter's cameras and China's Chang'e orbiters, shows a landscape of extraordinary complexity. Ancient mountains, vast flat regions, chains of craters. Material excavated from deep within the Moon's mantle, exposed at the surface and visible in spectral data as mineralogically distinct from the surrounding terrain. But the images are only part of what the SPA Basin reveals. The Grail gravity data showed something that orbital photography alone couldn't capture. Buried beneath the basin floor, at least 300 kilometers below the surface, is an anomalous mass of dense material weighing a minimum of 2.18 quintillion kilograms. That number is difficult to put into human scale perspective. Peter James, a planetary geophysicist at Baylor University who led the team that identified this mass anomaly, described it as roughly equivalent to burying a pile of metal 5 times larger than the big island of Hawaii underground. The mass is dense enough to measurably distort the local gravitational field, dragging the basin floor downward by more than half a mile, relative to where it would sit without the buried mass pulling on it. The most likely explanation is that this buried mass is the metallic core of the asteroid that created the SPA basin, the impacting body's dense iron-nickel core, which survived the impact and lodged in the moon's mantle rather than being vaporized or ejected. Like a bullet fragment that the body's tissues grew around and never expelled, the core of the impactor may still be sitting there, 300 kilometers underground, 4 billion years after the collision. If that is correct, it means the South Pole Aitken Basin is not just a scar. It is a tomb for the object that created it. In 2023, a research team led by Matt Siegler at the Planetary Science Institute published findings that quietly unsettled a significant portion of what scientists thought they knew about the far side's interior. Using thermal data collected by the Chang'e 1 and Chang'e 2 orbiters, combined with detailed analysis of the far side's topography and crustal structure, the team identified a region on the far side, approximately 50 kilometers wide, that registers roughly 10 degrees Celsius, warmer than everything around it. Not dramatically warmer, not a volcano, just a persistent, localized thermal anomaly that has no obvious surface expression, no crater, no volcanic deposit, no feature visible in the photographs that would explain it. The source, the researchers concluded, is almost certainly a buried mass of granite. On Earth, granite is one of the most common rocks you can find. It makes up a significant portion of the continental crust. It forms in environments where magma cools slowly, deep underground, with water present to facilitate the crystallization process. It is utterly unremarkable on our planet. On the Moon, granite should not exist, or rather, it should not exist in the way that this thermal anomaly implies. Granite requires 2 things to form that the Moon is not supposed to have had in relevant quantities: water, which facilitates the magmatic processes that produce granite, and a mechanism for concentrating silica-rich magma through multiple stages of differentiation. The Moon is generally believed to have lost most of its water during the violent impact that formed it. Its volcanic history, while extensive, is not the kind that typically produces large bodies of granite. Yet the thermal anomaly suggests a body of granite roughly 50 kilometers across, sitting beneath the far side surface. A remnant, most likely, of a volcanic system that was active approximately 3.5 billion years ago and has been slowly cooling ever since. Siegler described the finding as looking far more like what we see on Earth than anyone had thought possible on the Moon. The finding raises a question that nobody expected to be asking seriously in 2023. If there is a 50-kilometer body of granite hidden under the far side that we only found because of a subtle thermal signal, what else is hidden under there that we haven't detected yet? The Moon has no global magnetic field, hasn't had one for billions of years if it ever had a strong one at all. The Moon's interior has cooled to the point where the convection in its core that would be needed to sustain a global magnetic field is either extremely weak or effectively absent. This is well established. But scattered across the lunar surface, particularly concentrated on the far side, are regions of magnetized rock. Patches of crust that behave as if they were magnetized when a magnetic field existed, preserving an imprint of that ancient field in the rock, the way a recording preserves sound on tape. These crustal magnetic anomalies are ghosts of something that used to exist. Remnants of a period when the moon had a stronger magnetic environment. They are also deeply strange. The largest and most visually dramatic manifestations of these magnetic anomalies are the lunar swirls, bright, swirling optical markings on the moon's surface that have no topographic expression. They are not craters. They are not volcanic deposits. They are not elevated or depressed relative to the surrounding terrain. They are simply bright, curving patterns of lighter-colored rock that show up in photographs and that align perfectly with the localized magnetic anomalies beneath them. Reiner Gamma, on the near side's western edge, is the most famous example and can actually be observed with a good backyard telescope. It looks in orbital photographs like someone dragged a white paintbrush across a dark surface in sweeping curves. There is nothing like it anywhere on Earth. Its origin is debated. The leading hypothesis is that the magnetic field of the underlying crustal anomaly deflects solar wind particles that would otherwise darken the surface through space weathering, preserving the original brighter color of the rock beneath in the areas of strongest magnetic protection. The swirling pattern reflects the geometry of the magnetic field. But this explanation, while plausible, doesn't fully account for all the characteristics of lunar swirls. Some swirls don't correlate perfectly with their associated magnetic anomalies in ways that the solar wind shielding hypothesis would predict. Some have brightness patterns that suggest additional processes at work. The origin and maintenance of lunar swirls remains one of the more actively debated questions in lunar science. What is certain is this: the moon's surface preserves a magnetic record of something, possibly an ancient internal dynamo, possibly the influence of major impacts, possibly both, that no longer exists. The far side, where the crustal magnetic anomalies are particularly concentrated, is essentially a map of something that died billions of years ago, still legible in the rock. Among the most practically significant and scientifically intriguing features that orbital imaging has revealed on the far side and across the moon generally are the lava tubes. When lava flows across a surface, the outer layers cool and solidify while the interior continues to flow. When the eruption ends and the lava drains away, it leaves behind a hollow tube of solidified rock, a tunnel formed naturally by the lava flow process. On Earth, lava tubes exist in volcanic regions like Hawaii and Iceland, and they can be quite large. On the Moon, where gravity is 1/6 of Earth's, and the lava flows of the ancient Maria were far larger in volume than most Earth eruptions, the lava tubes may be on an entirely different scale. Orbital radar data and high-resolution imaging from the Lunar Reconnaissance Orbiter have identified features called pit entrances. Vertical shafts dropping into the lunar surface that appear to open into underground voids. These pits are not impact craters. They have the wrong morphology and the wrong geometry. They appear to be collapses in the roofs of lava tubes, exposing the underground space beneath. Theoretical models combined with the radar data and the geometry of the observed pits suggest that some of the underground voids these pits open into could be enormous, potentially kilometers wide and many kilometers long, large enough, in theory, to shelter structures of significant size from the radiation and thermal extremes of the lunar surface. This is not speculation about ancient alien construction. The physics of lava tube formation on the Moon, given the scale of the ancient eruptions and the lower gravity that would allow larger structures to remain stable, genuinely supports the possibility of very large underground spaces. What might be inside them? Trapped gases from ancient volcanic activity, pristine volcanic deposits that have never been exposed to space weathering, temperature conditions dramatically more stable than the surface, is unknown because no mission has yet entered one. The far side has its own collection of these pit features, in addition to the ones identified on the near side. And the far side's thicker crust, combined with its different volcanic history, may have produced lava tube systems with different characteristics than those on the near side. Whether they are larger, smaller, more structurally stable, or differently distributed is genuinely unknown. They are there. They are sealed. And what is inside them remains one of the moon's most tantalizing unanswered questions. There is one property of the far side that has nothing to do with geology or impact history or crustal thickness. It has to do with what the far side blocks. The far side of the moon is permanently shielded from Earth by 3,474 kilometers of solid rock. Every radio signal generated by human civilization, every cell tower, every broadcast antenna, every radar installation, every satellite downlink, every Wi-Fi router on the planet is blocked completely and continuously from reaching the far side. The electromagnetic noise of an entire technological civilization, which fills the radio spectrum around Earth so densely that it obscures astronomical observations from the ground, cannot penetrate to the far side of the moon. For radio astronomers, this makes the far side of the moon the most electromagnetically quiet location in the inner solar system. It is a natural radio-silent zone of extraordinary value. The most scientifically compelling application of this silence involves low-frequency radio astronomy. Observations at frequencies below, about 30 megahertz. Earth's ionosphere, the upper layer of the atmosphere that is ionized by solar radiation, blocks these frequencies from reaching the ground. It is essentially opaque to low-frequency radio waves, which means that ground-based radio telescopes cannot observe at these wavelengths at all, regardless of how far they are from human-generated interference. A radio telescope on the far side of the moon would be shielded from human interference by a wall of rock, and shielded from the ionospheric blocking effect, because there is no ionosphere. It would have access to a window of the radio spectrum that has never been observed from any fixed point. A frequency range that contains signals from the cosmic dark ages, the period before the first stars formed, when the universe was filled with neutral hydrogen emitting faint radio signals that have been traveling toward us ever since. China's Chang'e 4 mission, which landed in the von Karman crater on the far side in January 2019, carried a low-frequency radio experiment as part of its payload. The first such experiment ever placed on the far side. The data from that experiment is still being analyzed, but it has already confirmed that the far side radio environment is dramatically quieter than anything achievable from Earth or from Earth orbit. Multiple space agencies have proposed more ambitious far-side radio telescope arrays that could image the cosmic dark ages in a way that no other observatory ever has. The far side of the moon is strange in its geology and unsettling in its asymmetry. It is also, in this one specific way, one of the most scientifically valuable pieces of real estate in the solar system. Not because of what is there, but because of what isn't. China's Chang'e 4 lander and its Yutu-2 rover, operating in the von Karman crater on the floor of the South Pole Aitken Basin since January 2019, have been doing something that no spacecraft had ever done before: conducting ground-level geological investigation of the far side. The findings have been significant. The Yutu-2 rover's instruments detected minerals in the von Karman crater floor that were not predicted to be present at the surface in significant quantities. Specifically, olivine and pyroxene, minerals that are common in the lunar mantle but should be buried deep beneath the crust under normal circumstances. Their presence at the surface of the SPA basin floor is consistent with what the impact that created the basin would have done, excavating so deep that it punched through the crust and brought mantle material to the surface. This is direct, ground truth confirmation of what orbital spectral data had suggested: that the SPA basin impact dug all the way through the far side's crust and into the mantle beneath. The material U-22 detected has been sitting there since the impact, exposed on the surface, providing a window into the Moon's deep interior that exists nowhere else on the lunar surface, accessible to current missions. In 2024, China went further. The Chang'e 6 mission landed in the Apollo crater within the SPA basin, collected samples from the far side surface, and returned them to Earth. This was the first time material from the far side of the Moon had ever been brought back for laboratory analysis. The samples are still being studied, but early results have already shown compositional differences from the near-side samples returned by Apollo and by China's own Chang'e 5 mission. Differences that are helping scientists understand the mechanisms behind the near-side, far-side asymmetry. The far side is no longer entirely inaccessible. It is being explored carefully and incrementally by robotic missions. What those missions are finding is confirming that the strangeness visible in the orbital images reflects genuine and deep differences in the Moon's geology, composition, and history. We looked at the Moon for thousands of years and convinced ourselves we understood it. We were looking at half of it, and even that half, as it turns out, we did not fully understand. The near side, the face that has been the subject of every painting, every poem, every navigation chart, every scientific paper written before the space age, is the unusual half. The volcanic plains that give it its familiar face represent a geological process that, for reasons still being debated, occurred predominantly on the near side and left the far side almost entirely unaffected. The far side is what the Moon looks like when that process didn't happen. It is older looking, more heavily cratered, more primitive in its surface geology. A record of the early solar system's bombardment history that the near side's lava flows partly erased. In that sense, the far side is not the strange half. It may be the more representative half, the one that shows us what the Moon fundamentally is beneath the relatively recent volcanic veneer of the Maria. But even that framing doesn't fully capture what the images show. The asymmetric crust, the buried mass in the SPA basin, the thermal anomaly that implies granite where granite shouldn't be, the magnetic ghosts printed in the rock, the sealed lava tubes of unknown size. These are not features that fit neatly into any single model of how the Moon formed and evolved. They are pieces of a puzzle that keeps turning out to have more pieces than expected. The real images of the far side, 60 years of them now, from blurry Soviet photographs to the sharp orbital imagery of the Lunar Reconnaissance Orbiter to the ground-level views from U-22, show something genuinely weird. Not weird in the sense of inexplicable or impossible. Weird in the sense that the Moon is more complex, more varied, more geologically interesting and more poorly understood than the comfortable story of a dead grey companion ever suggested. We are going back. Artemis will eventually send humans to regions of the Moon that no Apollo astronaut ever saw. China is planning additional far-side missions. The scientific questions driving those missions are real and significant. And the images that started it all, those blurry Soviet photographs from 1959 showing an alien landscape that no human eye had ever seen, were the first hint of something that 60 years of increasingly sophisticated observation have confirmed. The Moon has been hiding something. It has been hiding half of itself. and the half it was hiding is strange in ways we are still learning to describe.